And it's pretty interesting things here that you can do diagnostically. Matt,
Yeah,
how?
just want to make sure. Can everybody hear me?
Yes, indeed.
Perfect. Yeah, my name is Matt Rigdon. I'm the Chief Technology Officer for American Amplifier Technologies. Like Barry said, back in April at NAB, we announced and kind of released the EmPower platform. And kind of before I get into that, and I'm going to spend a little bit just kind of with a bit of a kind of here's who AAT is, and then I'm going to get to the fun stuff, which is where I'm going to jump into an actual demo of our platform in action, just because
Okay.
I think that's the fun part, right? That's the stuff that we all enjoy. Um, and uh, Feel free kind of throughout to interrupt if you have questions. Um, I I want this to be interactive, not me just kind of like going through a bunch of stuff. Um, so kind of with that, a little bit about AAT, and this has changed even somewhat recently, which is um, we are more than just American Amplifier Technologies. There's a lot to who we are as a company. As you can see here, this is American Amplifier Technologies as a whole. So yes, we've got AAT as the parent, but we've got our services team with SWE Services. We have our Mana Towers business where we own several tower sites in Hawaii. EmPower, which is what we're going to spend a lot of time talking about. In 2023, we acquired Shively Labs, and recently, September 1st, we acquired Katrine Broadcast USA, which is Katrine and Scala antennas. So that is really a big part of who we are as a company. AAT really encompasses all of this, but the reality is um, there we have a lot to offer our customers, and we don't look at ourselves as a vendor, but as a partner who can come alongside, who can provide solutions to problems that you may have, or solutions to the things that you need, rather than just a manufacturer, not just a service provider, but truly a partner. And we like to work with groups like Broadcast Depot to extend that partnership as well. Um, because of that, right, we have an extensive line of products that we offer from transmitters to coax, connectors, filters, combiners, monitoring equipment, um, antennas. All of that is a big part of what we can provide from a product perspective. The newest offering really in that product portfolio is the EmPower platform. And so we understood the challenge, right? Is that modern broadcast systems are complicated. There's a lot of interconnected systems. Downtime, failures or downtime, that's lost productivity, that's higher costs, that's lost revenue. We wanted a system that could help provide visibility quick and easy. Like most manufacturers, remote control access has always been a big thing in all of our products, right? All of our products have web interfaces. All of our electronics products have web interfaces, support SNMP, that kind of stuff. But what we wanted to do is take that to the next level, provide greater access and visibility to broadcasters. And beyond that, take it to the point where not only are you gaining that access and visibility, but this is where our EmPower ecosystem or platform really comes into play. It's not just remote control, it's not just remote access, but the EmPower platform comes with a mobile app, which is something very new, I think, in a lot of ways in the broadcast space. A lot of platforms are mobile friendly. This is an app that you go download from the App Store, whether it's an iPhone or an Android device. You go download it from the App Store. You now, anything that has EmPower enabled will let you access that data directly in the app. You get push notifications right in the from the app. You're able to get in quickly, easily, no complicated network changes to your firewalls or anything like that, but it's built to be secure, robust, reliable to get you really that visibility that you need, whether on a small scale or on a large network level scale, you can gain that visibility that you need. Um, and obviously, why that matters is because it allows you to be proactive, more efficient, and again, scalable and more future ready. Um, and like I said, that's it on the slideshow side. Now we're gonna jump into the fun part, which is the actual platform. One quick note before I jump into that. So we've built what we call the EmPower controller. The controller is our remote control platform, but before that even started, hold on. Before we got to, oh, that's weird. Um, Before we got to the controller side of things, we actually started with the mobile app and we started building some of our new electronics products with the app in mind. So we actually started with our EC series voltage monitoring platform, built the app, then we upgraded our RF power meters to include mobile app support. Then we built the de-icer controller that has the mobile app integrated. But then as we were looking at it going, hey, there's a whole lot more than just those products at a transmitter site that could benefit from access to the mobile app. And that's how the controller was born. And so the controller that now takes any SNMP enabled device, brings it into the controller, and then gives you access to all of the to that device in the mobile app, but is also still a standalone remote control platform with a lot of features and capabilities that we're gonna get into here. And so I'm going to start by bringing this in to the controller. But yeah, so first thing you get is the dashboard. And what we try to do with the dashboard is make it simple and easy. So adding things to the dashboard is as simple as a checkbox. So rather than trying to build complex interfaces to add in all the different things. If you want something to show up as a metric in the list down here, it's just a checkbox. If you want a gauge that shows you more of a, kind of your traditional gauge style, it's a checkbox. Same thing with the actions here. It's just a checkbox to add that stuff to the dashboard. In this case this is a unit back at our shop. The dashboard also includes two other pieces. So you've got our SNMP devices. So any SNMP device here would show up as a card. And this is just kind of your quick view of each device. And then for each of those, you can jump in and see what's going on with that. So in this case, I've got a forward power fault.
How many devices total?
So the base unit supports 10 devices. You can add additional devices with additional licensing. Depending on the version that you get. So for the base controller, we have a version with and without IO, but we also have a version that is software only. And then we now have a version of the controller that has an embedded VNA where you can actually do automated TDR analysis. It's the full controller platform with a VNA embedded in the unit so that you're able to extend the capability of the platform. So you get the controller and VNA all in one box. The right now there is a limit of about 30 devices. That's IP addresses essentially on the hardware version of the controller. We're likely going to bump that up and that'll just get bumped up with a software update for the max. So from a licensing perspective, the base unit comes with 10 devices. You can add up to 2 packs of 5 additional licenses. After that, the what we have is called a max pack, where it basically unlocks the maximum number of devices supported. So on the virtualized version, there is no fixed limit. It's just a matter of you assigning more resources to your computer environment. On the hardware version, it's currently capped at 30. We're probably going to bump that up to 50 devices. We're trying to make sure that we don't sacrifice performance as we add more devices. So that's where that balance of devices comes into play. This particular unit that I'm using also has embedded I/O in the unit. So with this, you'll also have your I/O state as part of the dashboard.
So essentially you could put like the controller without the I/O, like at the studio, and have that as your SNMP manager,
Mhm.
and be able to gather your data from, and it will take data from any device that has SNMP, correct?
That's correct.
Okay.
Yeah.
Okay.
So
Yeah, because there's some of us that have large networks of stations. I've got 19 here in Nebraska. And, you figure 4, maybe 5 devices per station to get data from. That adds up pretty quick. So that's why I
Right.
wondered how many devices. Thank
Yeah.
you. Go ahead.
Yeah. So with the SNMP side of thing, this is where we spent a lot of time really wanting to make sure we can make it simple and easy to use. Implementing SNMP often can be cumbersome. So what we've built is this idea of you import the MIB file for SNMP. Once it's imported, the system will automatically pull in the data and build you a table with all of the information available. From here, you can then configure how a particular and what I'm showing you is the current release version of software. I will spend a few minutes at the end showing you our development version that we are working on with some new features that are going to be coming in a software release here, probably in the next couple weeks. So in this case, once you've got the MIB loaded in, this is where you're then able to tell the system what to do with each of the different values that it's reading in. So in this case, this is connected to a transmitter that's at our shop, one of our TXN series transmitters. And you're able to give it a more user-friendly name, can determine what units you're presenting this information as, decide whether you want to pull the data, how often you want it to update the data from the SNMP device. And then, like I said, this is where, hey, if I want to include it in that metrics view, or if I want to display it as a gauge, these are those checkboxes where if it's checked, it shows up on the dashboard. You're also able to go in here and apply some kind of transformation to the information. So in this case, a lot of SNMP data comes in as just integers for numbers, but I know that I need to convert that from one value to another. That's where I can actually scale and offset that. I can display it as a floating point number, anything like that, so that I actually read the data in the way that I want. This is also where I can apply some fault detection. This will do our basic alarming. So in this case, because it's a number, I've got a minimum and maximum threshold. You've got your hysteresis, which is kind of your debounce, and then your fault persistence, which is your delay before a fault is actually triggered. In this case, because this is a read object, there's no commands to set. if I go to nominal power. So in this case, this is where I can set my power levels. This is where I can create my commands for, hey, I'm going to preset this power to 1,000 watts. You have all the different, so in the case of commands, you can define preset values where a button is created that just does that one thing. In this case, I've set a fixed command to set power to 1,000 watts. I can give it a description. I can require confirmation when the button's pressed before the action is actually executed. And again, I can include it on that dashboard, and I can even customize the prompt. Or another option is, in this case, I'm using a user input, which means I can give people the ability to set a custom power level or a custom value, but then I can even limit the range in which that value is settable to. So if I know that my TPO is 1,500 watts, I'm going to hard limit that to 1,500 watts so that someone can't go in and set it to 2,000 watts or 3,000 if my transmitter goes that high. I can lock that in to a specific value. I can remove any of these. The first time you enable commands on an object, it'll automatically go through and determine a preset set of commands that might be valuable. Some objects it does it for, some it doesn't, just because certain objects there's just nothing to kind of determine a preset. From this, you can also do a test where you can actually test those commands before you kind of finalize things. That'll actually send real commands to your unit. In this case, I'm going to go back to my dashboard. Close Windows Update. You can see here, my nominal power setting is currently set to 100 watts, but I'm not getting any forward power because the unit's off. So in this case, I'm going to turn my transmitter on. You can see that it was executed, and then I've got this set to update every 5 seconds. And now you can see it's on. In this case, we're going to set it to 350 watts. You can see here, transmitters coming up and getting to about 350 watts. And then over here, I can see, okay, I've got a status. It looks like, well, I've got a fault because my forward power is less than 400 watts, which is what I currently have my forward power fault set to. And then, let's see. So I mentioned that the app is available on the App Store, but there's also a web version of the app. See if I type that right. Nope. Go. And let me make sure here. So adding your controller to the app is pretty simple. Let's make sure. Log out of that. Let's actually do. So to add it from the app, you either scan this QR code or you just copy this client ID right here. Yeah. And this right here is the app version of that controller that we're messing with. And then in my case, I can see here. Where did my cursor go? Right here, I got a notification, which I received as a push notification on my app on my phone, but also have a notification in the app here that I had a fault for low forward power. So once I've got my MIB set up the way I want, I've got all the settings for faults and commands. Then all I have to do is tie it to a device, which in this case, that's right here. So if I want to add a device, I just put in the name, location, IP and SNMP info, and then I can pick the MIB that I want to use that I've configured. Any questions at this point? Since this unit is enabled with I/O, we've got our basic I/O, we've got analog, digital inputs, and relays available on the system. In this case, I've got here my analogs configured. I can see that this is degrees Fahrenheit. I'm averaging my reading. This is included in that overview. And then you come back over here and you see that I've got that analog input right here. In this case, there's not really anything hooked up to it. For analog I/O, you have the ability to calibrate the channel. We've done something a little bit different with the way we've done calibration. So there's kind of two different ways that you can go about doing calibrations. You can use known calibration information. So in this case, we've built calibration presets based on known values. So in this case, just an actual voltage, a temperature sensor, a pressure sensor, or you can build a custom curve if you know the calibration curve. The other thing you can do, so beyond that, is we've built in the ability to support different types of calibration. So not just linear, but logarithmic, exponential, power, and power. So that's, you can build kind of the calibration data yourself. Otherwise, you can calibrate the channel. If you know the type, you choose that here. Otherwise, you can do an auto detect. To do an auto detect, though, you do have to have a minimum of 5 points. So this is really good for something like your transmitter, where you can turn your transmitter on, adjust your transmitter, set it to different values, and then actually read the different values at those different states. And from here, you build that out, and it will automatically build out and assign the calibration curve type based on the calibrated value that you detect, or that the system detects. For same thing with your analog I/O, you're able to configure your faults from right in here. Anytime a fault is configured in the system, that automatically ties to a push notification in the app. And then it's not in this version, it's in the version that we're building right now. The controller will have built-in email function, but also with the app, you can configure your app to send you emails. So with the app, if you want to just turn this on, when you enable that feature, any notification that you get in the app will automatically get copied to your email as well. With the digital inputs, you've just got your basic relay input. You can invert the logic and again, build your fault and include it in the overview. And then for your relays, you've got your basic relay configuration.
Will you guys be looking at SMS or text of alarms?
Currently, we don't have a built-in feature for SMS alarms.
Okay.
We have done some exploring for it. The unfortunate challenge for I think a lot of us is several of the carriers have removed or eliminated their email to
Yeah,
text feature.
yeah.
Um, so we've done some research on it. If it is a feature that people would need, we can definitely look into adding that.
Okay. As I have found in a lot of cases where the text messages come through faster than the actual emails do.
Right. Well, and that's
Mm.
where, so if you have the app installed, you'll actually get a push notification on your phone.
Oh, that would be good. Sure.
Yeah. So in
Mhm.
fact, when I was messing with this, because I have that device connected to my app, I was seeing notifications pop up on my phone
Uh-huh.
as I was going through this demo. Um, and I think I could show you guys how that works in a few minutes. Um, but yeah, so that's the IO. There's not a whole lot going on with the IO. Going back to the dashboard, though, what you can see here, in this case, just for testing purposes, I have this relay tied to this input. So when I activate that test relay, my test input on my digital input goes active or goes high because I just turned it on. Um, and then I can deactivate that, and you'll see that goes low. After the setup of all the inputs, SNMP, your analog and digital IO, and your relays. Uh, Now we've got our action engine. So this is where you can build automation into your platform. This is where you can build that intelligence that says, okay, when certain conditions are met, this is where I'm going to automate it and do different things. So the one I often use as an example is temperature. A lot of devices anymore have an ambient temperature sensor, and then maybe you've got an SNMP enabled HVAC system, and so you want, instead of relying on one source of truth for temperature, you want to rely on a few before you do things like turn down the power on your transmitter or anything like that. So in this case, with our action engine, you can take any input, whether it's a digital input, analog, SNMP, or you can actually use an action to trigger other actions. So you can use actions as inputs. So in this case, what we consider we have what are called building blocks. A building block is an action that only has input conditions and no outputs. So in this case, I've got my analog input configured that if it goes over 100 degrees in this case, it's going to trigger this action to go high. In this case, because I think Um, and then if I go over here, I'm going to say, okay, that's my room temp building block. Now I'm going to go to my room temp action, and I'm using that action as my input condition for this. And then I'm going in here and I'm saying, okay, when that condition is met, I'm going to now trigger this command to set my power down to 250 watts. I'm also going to send a custom notification to my app telling me that the room is hot and I set the power to 200 watts, letting me know that I've actually triggered that action. So I get a push notification. And again, if I have those notifications tied to my email, I can get that email as well. In this case, let's say I want to use that, but I want to actually read a separate analog input as well. I can build a separate condition in here that says if both that action and this analog input condition are true, then it's going to trigger that action. This is where I can stack multiple conditions and either make them all true, one of them has to be true, or none of them have to be true to trigger this action. I'm able to build that logic in here once I start adding multiple inputs to my action. After that, then those actions will then trigger these things. So in this case, because I don't actually have anything hooked up to my analog input, I'm going to just set this really low and now you can see, look, this was triggered, that's triggered. So now both of those conditions are triggered. And so now it's actually changing my power level to that. So in this case, I'm going to go back here. I'm going to disable that action real quick. I'm going to go in here. I'm going to set my nominal power to 500 watts. Yep, there we go. Now I'm going to go back to my actions. I'm going to actually re-enable my action. Now it's executing and it's triggered. I'm going to go back to my transmitter. Now I'm going to see my nominal power just got set back to 250 watts because those actions were triggered. Beyond automating actions, then you've got logging, which is super important. So we've built a logging engine. So instead of logging data by default on everything, what we've done is we've built the ability to build data loggers that collect log data for specific inputs. So in this case, I'm measuring forward power. So I've got this connected to my SNMP. I'm reading that nominal power, which technically
You guys have an integrated way in which you could send that to like a Splunk or kind of big data, Datadog type of environment?
um currently no, but I will make a note to do that. It wouldn't be hard. At least not automated, but I will show you we do have the ability to export the data, just not automatically,
Figured
right?
as much, right? Could probably throw it to a database, then do like a heavy forwarder or something like that. But
Right.
was just curious.
Yeah. So what as I'm collecting my data, then I go to my data viewer. This is where I can choose the object that I want to read. And this here is where you can export either a JSON or a CSV of this particular log data. And what this is showing you here is this is what the data has been measured over the last 24 hours. I can change this time range. I can also view the data just as a table myself to see. And then even here, I can see when there's no data because there was a problem.
And I joined a little late, but did you tap anything about like API functionality to this? Or is there any plans for that?
As far as remote API access,
Well, in my realm, I would love to take my ATT amplifier and pipe it through like an orchestration module, like an N8N, so that we could do analytics on its telemetry and kind of make decisions of what we wanted to do based on that.
so we are actually in development of another capability. So right now the core function supports MIBs for SNMP. We are in
Hmm.
development on a feature set to actually add API support where you can actually connect this to an API and read data from an API and
Okay.
essentially write data to an API as well.
Yeah, right now I'm piping it all to the cloud from the transmitter, then kind of hooking it out of that and seeing what it looks like. So that's
Yeah,
awesome.
so yes, we are building API support into the controller as well.
Great.
The last thing on the data logger side is the live dashboard. So all this is really helpful for is if you're trying to diagnose kind of real-time information. So when you go to this page, it just starts displaying in real time the log captures that are happening in the back end based on your data logger configuration. So in this case, I have my forward power and my room temperature set to update every 5 seconds in a 5 second interval. And so you begin to see this update in real time as we're gathering. This is great if you're diagnosing some weird, fluctuations or things where you can just grab this page and just see what's happening in real time. This has no impact on what's happening on the data side and the data capture side. This is really more about just giving you that quick visual in real time of what's going on. When it comes to the logs themselves, there's several different ways in which you can capture the data. Um, in this case, you've got your interval, which is, hey, I'm just going to capture this data every 5 seconds. You've got a daily, which is just a single snapshot. a weekly, or a monthly. All three of those are really just snapshot based or in time based captures, where if you only need to capture something once a day or once a week, you just grab that quick snapshot and you're done. Otherwise, you use the interval. In the new code, the interval also has the ability to put a time bound around the interval. This actually came as feedback from an engineer we're working with, and who has an AM, and they wanted to only capture certain log data between the hours of like 6 p.m. and 6 a.m. And so what we've done is added the ability to do an interval capture during a time window, and the time window can span overnight, right? So it doesn't have to be in a 24-hour within a single, day. You can say 6 p.m. to 6 a.m. and it will capture overnight. So we've added that. The other things you've got here is just the ability to determine how many days of log data are going to be stored, or the maximum number of records that you want to store. Most of the time, you're going to probably leave the record count alone, and just decide your day count. In your history log, this is where you've got your basic capture of faults and your basic info. This is also where your typical system logs are stored as well. And then, like all of our platforms, you have the ability to add users. Users have three access levels. You have an admin who can do everything. You've got your controller who has the ability to basically control any of the actions and different things, but can't add or delete things. And then you have your monitor who can see but who can't execute a single command. It's just about visibility, not about visibility and control. Basic setup page. Like I said, this is how you add the app, the controller to your app. Any EmPower enabled product from AAT will have this EmPower setup enabled. And like I said, you either scan the QR code or just copy and paste that client ID into the app, and you've added it to your app. It's that simple. It relays through our cloud service and then available in the app. If you want to disable communication with the app, you just disable the communication. Not much else going on the About page other than this is where you do your firmware updates to the unit. So as we're releasing new features, we'll provide firmware updates to customers who can just grab that firmware, load it into their unit, and they're ready to go. Any other questions at this point? I'll go back into the app and kind of work around the app now. So in the case of the app, you've got your main, just like in the controller, there's a dashboard in the app. The first page of the dashboard is going to be your favorites. This is where you're going to be able to favorite a single device. And then we have two ways of grouping devices. The first is sites, where you can put your devices into a site. The other way is to build customized groups. So in this case, I've got a group for all transmitters. So now I can put all of my transmitter devices in a group. Or if I come over here to my sites, in this case, I've got this one site, and then all of my devices that I tie or connect to that site show up in here. For a site, the basics, as long as you have city and state, then what will happen is your site will show up on the map view, which will give you visibility into all of your sites across, your network. So if you have more than one site, the map automatically scales based on the position of all the different points on the map. So as long as you have city and state, then we're able to place that site onto the map. If you don't have city, state, or latitude and longitude, then the site won't show up on the um, on the map. It also gives you a list of active faults and devices. But then on the dashboard, like I said, you've got favorites. This is where I can decide I want things quickly made available here. I've got my sites. I can make a site or a group a favorite, and that shows up in that favorite section. And then I've got my device list, and this gives me all the devices that I have currently connected to my system. The way the cards work in the app is the cards for a device show you the status or state of the device. Gray is typically offline. Then you've got yellow, which has a handful of conditions, red, which is a high fault condition, or green, which is okay. Our default sort is that we're going to put the more important conditions, so the error conditions up at the top. The anything that's okay will get kind of deprioritized. You can customize the sort, and you can search and filter within the view. When it comes to a site or a group, in this case, I'll use the group as the example. The card at the each card is the worst condition within the entire group. So let's say I have all transmitters in this group and I've got at least one transmitter with a fault. Then my card is going to be red because I've got a transmitter with a fault. If all my transmitters were good, that card would be green. So it's going to take the collective status of the group and it's going to determine the condition. And then that's what you're going to get presented on the card so that you know, again, what you need to address first rather than having to dig in to determine, oh, hey, is all my transmitters. Once you go into a custom group, there's two different views you can have. A group can have devices. It can also nest other groups. So in this case, maybe I want a group that is all transmitters, but then I want a California transmitters and Washington transmitters and Portland transmitters as separate groups. I can do that within here and then again nest those groups together. And then we're working on the app side of this feature, but that logging that's available here in the controller, we'll be pushing some of that data up here to the app as well. So you'll be able to gain access to that log data within the app. And then that's the app. Our goal really was to build a platform that was simple and easy to use, minimal customizations. I am going to take a second and I am going to switch to my development instance and I will show you some of the features that we're in the process of finalizing that'll come in a firmware update here in the next couple weeks. While I'm doing that, one of the things about what we have built is the controller. Let's see, hold on. Apparently I can't multitask very good right now. Where am I going? So the thing about the controller is with the we are constantly building features in development. Hold on, I can't see the window I'm trying to look at. There we go. Okay, you should see this. And we're constantly looking for feedback from customers on feature sets that we can continue to integrate. So this is, like I said, this is my development instance. We've made a few functional changes, streamlined a few of the views, such as the status. For MIBs, we've built now a templating engine that allows you to export a MIB that you've built as a template and then recall that template later so that you can apply it to other devices. So let's say you import the MIB for a transmitter of yours that, let's see if I can do that. Let's say you import a MIB for a transmitter. You get all the settings the way you want it for that transmitter. Once it's set the way you want it to, then you can export that. And let's say you have multiple controllers, you have a controller at every site, but it's the same transmitter. Now you can import that template and reuse it in different places. The other nice thing about the way the templates are built is there's a couple ways so once you have a MIB imported, you can set the different values that you want here, just like I showed you before. You can then save that MIB as a template. You can also export the MIB as a template, or directly on this page, you can import a template as a MIB. You can also just save the current MIB as a template. Once you've got that in your template library, you can still edit that template. So let's say you want to make changes to the way your template works. You can go in and just edit that template. And once you've done that, you can export it. You can apply that template as a MIB to be used connected to a device, or you can delete it off your system if that's what you want. And so we really wanted to make it to where you could reuse what you've built in different controllers in different places or within the same controller. So we built the templating engine on that. One of the other things that we have done is put some helpers in. So in this case, on the display setting, we built the ability to kind of help build your offset. So in this case, if I know that the system is giving me my power in milliwatts, but I want to display it as kilowatts, it'll automatically figure out what that offset and calculation value is and apply it there. Or another example, okay, I know that I need to go from Celsius to Fahrenheit, right? In this case, I've automatically scaled or applied my scaling value to that. But hey, my system is giving me 730 as the value for 73 to, well, let's do this. We'll do 32. It's giving me 320 for 32 degrees. So I know that I need to offset that by 1 to get my 32, then calculate that. Now it's going to automatically apply. Oh, I did that wrong. Those scaling factors for me to this so that I can save it so that that value then reads the way I want it to. We've also added some helpers here just from the user interface side of things. Easier way to search and filter all the MIBs, especially for the more complicated MIBs that have maybe hundreds of different data points that you can read. This just gives you a quick and easy way to filter through that so that you can get to what you're trying to do. The other thing that we've done that's related to that is, this is my test system. Let's go dashboard. That's what I'm looking for. On this, we've added a filter or a sort capability for your metrics. So on a device on the SNMP dashboard, when you open this up, this is everything that you're monitoring for this device. So we've added a simple sort and filter capability, or not sort, filter. I'll get that right. A sorting capability, so you can sort by the name, the value, the unit, or status level. Same thing with the actions, you can sort them by name on that view. So those are just a couple of the features that we're getting close to releasing, but then also, like I said, we are working on API capabilities. We are working on several other capabilities similar. I'll make a note on the SMS integration, um, and on log export as well. Uh, and more specifically, automated export of logs to like a Splunk or something like that.
Yeah. Any way to kind of get it into any kind of larger scale data aggregation service.
Yep. Yeah, no, that makes sense.
Okay. Anybody have other questions? Press your space bar or alternate 8 or raise your hand. I think, Matt, this is quite a well-conceived product because integrating all these variables is really a good point.
Yeah, we really tried to take what we know broadcasters need and want from a platform, build a modern stack, a modern interface, simplify some of the complexity, and then with the mobile app, really put that in the palm of your hands, right? Eliminate some of the barriers that when you as a broadcaster are needing to see what's going on with your site, you're not having to go through the hoops of jumping through VPNs and any of that kind of stuff. You're getting it in the palm of your hands from the app. You can execute commands, you can see what's going on, get quick access. We actually had one of our customers that has a controller at a site tell us that he was sitting down for lunch and he got a notification from the app that the transmitter was off. Popped open the app, pressed the transmitter on button. Transmitter came back up and he went back to eating his sandwich, right? Like that's how quick and simple it was for him to go from I got a notification to I've got us back on the air while he was sitting down at the sandwich shop eating lunch, right? And that's the simplicity that we're trying to build in the platform for the users of the platform. So between the controller and then trying to natively integrate the EmPower platform into more and more devices, that's kind of the what we're trying to do for the customers. And then, like I said, we've got the VNA product that is an extension of the controller. So when you go to if you want the VNA option, currently you can get the VNA without IO, but we have an integrated VNA and it'll do automated TDR analysis. You'll get alerts. So you calibrate the system, and then what'll happen is the system will look for variances. If it crosses that threshold, you get an alert within the app automatically that there was a variance based on your kind of calibrated and reference signal. And that can just be running all the time in the background. And we're working on automating, and with that is also automated frequency domain to a point. There are some pieces that will need to be done, but the goal there is to streamline and reduce the amount of time that it takes to do your annual inspections when you need like a frequency domain analysis and different things like that. So we're just continuing to invest more and more in these kind of products to simplify life for the broadcaster.
Very good. That's what we need, simplified life.
What kind of price point are we looking at with these devices, these units?
For the controller itself,
Mhm.
give me 1 second and I will tell you. So our list price for the controller for the hardware version without IO is about $3,600. If you wanted to push that to the maximum number of devices it can connect to, it's about $5,900. If you want integrated IO with it's $4,900. All this is available on the website.
Oh, okay.
Like I said, we do have a software only version. If you have a virtual environment, we are also gonna be offering a subscription model for the software version where it would be the software only version. So you'd have to install it on like a virtual server somewhere, but you could do that as an annual subscription as opposed to a perpetual license. software only version you can also just buy as a perpetual license. You own the rights to that license and can continue to use it. That comes with all of these come with 2 years of warranty coverage, which includes all the firmware updates and everything. Any product that is EmPower enabled, whether it's the controller, the RF power meters, the de-icer controller, or our EC voltage monitoring system, the app is included with those as part of the purchase.
Okay, so the software version, is it strictly VM?
Technically,
or,
well, it would.
Or can you just install it on a machine? Or
I mean, technically, you could install it on a machine. We're not exclusively saying it has to be a VM. Technically,
Okay.
yes, you could install it on quote unquote bare metal if you wanted to.
Right.
Um, it's just a software license to the EmPower controller software. So essentially, what you're getting when you buy the software version is the EmPower controller hardware without I/O,
Yeah.
just without the physical hardware component. You're just getting
Right.
the software that
Right.
you install on any machine, whether that's your own bare metal, whether it's a VM inside a virtualized environment.
What OS would you have to put that on a standalone machine?
Sorry, say that
is
again.
it Windows or Linux or?
This runs on Linux.
It's a Linux. Okay. And then as far as maximum devices, is that something just in the software that one can get?
So on the software version, if you were to get the software version with the Max Pack, which basically unlocks, then really there's no limit applied, but we would recommend at that point that you pay attention to your system resources, right? And if as you add more devices, you just want to make sure you're adding more resources to the system if you need it. So
Okay, very good.
Could you theoretically deploy this like in the cloud, like a
yes.
DigitalOcean or AWS type of situation?
Yeah, you could. I mean, the reality is as long as you have access to the devices that you're trying to monitor, whether it's through a VPN tunnel, through a point-to-point link, or anything like that, as long as the controller has IP access to those devices, the controller could live wherever. So if you got the software-only version, yeah, you could put it on an EC2 instance up in AWS. And
What
if
version
you,
of Linux are you guys running on this one?
reality is it actually runs in Docker. So it's a little
Sure.
bit agnostic to that.
Fair enough.
Any other questions? Awesome.
Well, on behalf of our 50 or so viewers, thank you, Matt. Appreciate your presentation. Appreciate the thought that's gone into EmPower. Hope you'll come back to us again.
Yeah, I'd love that. I'm going to post my contact info in the chat as well.
Very good. Excellent.